Good morning, friends. This is Aditya Agarwal again, explaining about copper and its alloys. So let's start. Copper and its alloys, one of the oldest and most widely used non-ferrous metal in the industry. Properties of copper: soft, ductile, and malleable. Ductile means it's a property of a metal which can be drawn into wires, and malleable, it can be forged, rolled wire, and drawability. Worked in hot and cold conditions, light in weight, pleasing color. Copper has kind of brown goldish color, so it's a pleasing color, not too bright. And it has a property of excellent corrosion to resistance and high thermal conductivity, high electrical conductivity, as copper is an electrical conductor, good electrical conductor, so it's an high electrical conductivity. Non-magnetic nature and ease of fabrication, good machinability, and can be polished, plated for pleasing appearance, can be easily alloyed with other metals. Melting point of copper is 1083 degrees per centigrade. Density is 8.93 to 10 power 3 kg per meter cube. Young's modulus is 122.5 GPa. Tensile stress is 220 MPa. Hardness is 80 to 85 BHN. BHN is Brinell's hardness number. Next, we go for copper extraction. Extraction from its ore is called copper pyrites. Process: crushing of copper pyrites into powders, concentration mixed with water, filtering it, drying, air blown. Roasting: copper pyrites are combined with iron and sulfur, becomes copper iron sulfide, and mixed with silicon oxide and oxygen. Now let's see the equation what forms. 2CuFeS2 plus 2SiO2 plus 4O2 gives rise to Cu2S plus 2FeSiO3 plus 3SO2. Then the next process is smelting and converters, metallurgical process to obtain pure copper from impurities. Let's see the equation. Cu2S plus O2 gives rise to 2Cu plus SO2. Another process is electrolytic refining. It is done from a solution called electrolyte, comprised of sulfuric acid and copper sulfate. On passing the current to anode into the solution, pure copper is deposited on cathode. 99.95% pure copper is obtained. Now let's see applications of copper. Electrical conductor, pure power cables, telephone cables, computer network cables, and PCBs and connectors. Used in heat exchangers and heating vessels. Base coating on steel. Various applications where lightweight with good corrosion resistance is required, making alloy brass and bronze. Poisoners used as germicides, food chemical industries, water tanks, vessels, tubes, jewelry applications. Now let's see copper alloys. One is brass, which is nothing but copper plus zinc, and another is bronze, which is nothing but copper plus Sn, and gunmetal is Cu plus Zn plus Sn, and cupronickel alloys is copper plus nickel. It itself says the name. Brass contains of three types of brasses, which is alpha brass, which is more than 20% of zinc, which is also known as red brass, and beta brass is nothing but 20 to 30%, which is yellow brass, and alpha beta brass is 30 to 45% of zinc, and alpha is nothing but high ductile material, and B is increases strength. So we'll see types of alpha brasses. Red brass, which has 85% of copper, zinc, and it is soft and ductile, high corrosion resistance. Applications are all are same, like electrical conductors, condensers, heat exchange tubes. One is gliding metal, and low brass which is high resistance to corrosion. And commercial brass, copper is 90% and zinc is 10%. Excellent hot and cold working metal. Costume jewelry, rivets, screws, jewelry case boxes are made with this commercial brass. Now let's go for beta brasses. One is yellow cartridge brass, which contains 70% of copper and 30% of zinc, and Admiralty brass, which contains 70% of copper, 29% of zinc, and 1% of acid. Now let's go for alpha beta brass. Munz metal, which contains 60% of copper and 40% of zinc. And then lead brass, which is 60% of copper and 38% of zinc and 2% of lead, which contains leads to easy machinability. And forging brass, which contains 59% of copper, 39% of zinc and 2% of lead, which is suitable for hot working. Architectural brass, which is 57% of copper, 70% of zinc and 3% of lead, which is used for forging. Now let's go for bronze, which is nothing but Cu plus Sn. Possesses superior mechanical properties and corrosion resistance. Strength increases in tin content. Tin maintain less than 12%, else be brittle. Bronze can be shaped into wires, rods and sheets. Now types of brass. Bronze. Types of bronze. Bell bronze, which contains 78% of copper and 22% of tin, which the name itself says it is help making bells. Coinage bronze is 95.95% copper, 3% tin and 1.5% zinc, which is itself says the name, which is used for copper coins. And phosphor bronze is 88% of copper, 0.5% of pH, 10% tin, 1% zinc and 0.7% of lead. pH increases strength and ductility, resistance to corrosion. Lead bronze, 75% of copper, 5% of zinc, lead, tin, 18% of lead, 2% of nickel, which is used in bearings. And aluminum bronze, 89% of copper, 7% of aluminum, 33.5% of iron and 0.35% of tin. Fe is added to increase strength, hardness, resistance to corrosion, cold working operations, used in gears, propellers, cams, roller tubes. Manganese bronze, 50 to 60% of copper, 35% of manganese and remaining percent is iron, resistant to corrosion, hot working operation. And then silicon bronze, 95% of copper, 3% of silicon, 1% of manganese, 1% of iron. Silicon is added to add strength, harden and improve corrosion resistance. Used in casting dies, rolling, forging, hot work, pressing boiler parts. Next is gunmetal. Zinc acts as a deoxidizer, improves fluidity during casting. A small amount of lead can be added to improve castability and machinability. So in gunmetal there is copper, zinc, which I said why it is important, and tin and lead. So types of gunmetal are Admiralty gunmetal, which is 88% of copper, 10% of tin and 2% of zinc, resistant to corrosion, producing castings. Lead gunmetal is 85% of copper, 5% of tin, 5% of zinc and 2% of lead, which goes to high strength. pressure tightening apparatus like boilers, steam pipe, fitting, hydraulics, valves, and gears. The last but not least is the cupronickel, which is 70% of copper and 30% of nickel. Can be hot and cold worked, good corrosion resistance in seawater applications and seawater pipings. Now let's see the types of cupronickel. Monil metal, which is 29% of copper, 68% of nickel, and 1.25% of iron, and remaining is manganese, resistance to corrosion, good mechanical properties, used in chemical and food industries mainly. And K-monil metal is nothing but 29% of copper, 68% of nickel, 2.75% of aluminum, and 0.4% of manganese, and remaining is titanium, good mechanical properties, used in motors, ship propellers, and blades. So this was about copper, introduction of copper, extraction, and its alloys. I hope you understand this, and thank you so much. Signing off as Aditya Agarwal.